All right, in 9.1, we're going to learn about right triangle trig. So we're going to be solving right triangles. I know all of you learned how to do this in geometry last year, so it's going to kind of be a nice refresher. So we have 6 trig functions. They are sine, cosine, tangent, cosecant, secant, and cotangent. And then we have a nice right triangle here. Important things to note about our right triangle. We're always going to be talking about one of our acute angles. So we're going to have a right angle. This little box means it's a right angle. If we're talking about this angle here, it's going to have a little theta that just is like a name for an angle. It's like calling it x, but instead they use theta here. And then we're going to be talking about the opposite side, the adjacent side, and the hypotenuse. The hypotenuse is always, always, always opposite of the right angle. So just think wherever this little box points, that is your hypotenuse. The opposite side is always opposite of the angle we're talking about. So it's going to be opposite of theta. And then the adjacent side is right next to theta. So adjacent is right next to it. It's going to be touching that angle theta that we're talking about. So here are our right triangle definitions of our trig functions. So let theta be an acute angle of a right triangle. So theta is just whatever angle we're talking about. And these 6 trig functions are shown here. So sine is going to be opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. We can remember that with our little acronym SOHCAHTOA. So this just stands for sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Sine, cosine, and tangent are 3 main trig functions, and each one of them have a reciprocal function that goes along with it. So cosecant, the CSC, stands for cosecant, is the reciprocal of sine. So notice how sine is opposite over hypotenuse. Cosecant's the reciprocal, so it flips. It's hypotenuse over opposite. Secant is the reciprocal of cosine. So instead of being adjacent over hypotenuse, it's hypotenuse over adjacent. And cotangent is the reciprocal of tangent. So instead of opposite over adjacent, it's adjacent over opposite.
What was the last one?
Tangent and cotangent are reciprocals.
Cotangent, okay.
Yeah.
Thank you.
So then these 3 little formulas here just show you that they're reciprocals. So cosecant is 1 over sine because it's the reciprocal of it. So instead of sine being sine over 1, it just flips for cosecant. Same with secant and same with cotangent. Like sine would be sine of theta over 1. Cosecant is the reciprocal of it, so it flips. So now it's 1 over sine. So reciprocal just means that you flip it. So example 1 says evaluate the 6 trig functions of angle theta. So our theta is up here. Theta is not always going to be in the same spot, so you just have to look for which angle your theta is at. It's going to be one of the 2 acute angles, so it's up top here. So we have one side is 12 and the other side is 5. 12, do you think it's the adjacent, opposite, or hypotenuse?
Opposite.
It's the opposite because it's opposite of theta. And then what about 5?
Adjacent.
5 is adjacent because it's right next to it. But we're missing the hypotenuse. What do you think we can do to find the hypotenuse of this triangle?
Look diagonal to the right angle.
It's opposite of the right angle, but how can we find what this length is?
Cotangent.
So you have to use Pythagorean Theorem to find this. So you do a squared plus b squared equals c squared, where c squared is your hypotenuse. And a and b are your two sides. So it doesn't matter which one's a and which one's b, just as long as they're both of the sides of the triangle. C is always your hypotenuse. So we have 5 squared plus 12 squared is equal to c squared. What's 5 squared? 25.
25.
What's 12 squared? 144. That's equal to c squared. So it's 25 plus 144. 169. How do we find what c is? Because right now we have c squared is equal to 169. Take the square root of both sides. So what's the square root of 169? 13. Perfect. So our hypotenuse is 13. Now we need to find our 6 trig functions. So we have sine of theta, cosine theta, tan theta, cosecant theta, secant theta, and cotangent theta. So going back to that slide before, or just knowing, so katoa. What is sine? In terms of adjacent, opposite, hypotenuse, what is sine? Opposite over hypotenuse. So what's our opposite? Our opposite is 12, and what's our hypotenuse? 13.
13.
So sine of theta is 12 over 13. Now let's find cosine. Cosine, in terms of adjacent, hypotenuse, and opposite, is what?
Adjacent over hypotenuse.
Adjacent over hypotenuse. So what's our adjacent?
5.
5, and what's our hypotenuse?
13.
13. Now let's find tangent. Tangent is what?
Opposite over adjacent.
Opposite over adjacent. So what's our opposite?
12
12, and what's our adjacent?
over 5.
5. And then we find cosecant. Cosecant is the reciprocal of sine, so instead of being opposite over hypotenuse, it is hypotenuse over opposite.
Minus over adjacent. Oh,
So we just flip what sine is. So what's our hypotenuse?
13.
13, and what's our opposite? 12. Now let's find secant. Secant's the reciprocal of what?
Adjacent over hypotenuse.
It's the reciprocal of cosine, so it's hypotenuse over adjacent.
Adjacent.
So what's our hypotenuse?
13.
And what's our adjacent?
5.
So secant theta is 13 over 5. And lastly, we have cotangent, which is the reciprocal of what?
Adjacent over hypotenuse.
So it's the reciprocal of which one?
Wait, what?
It's the reciprocal of which? It's the reciprocal of tangent, so we flip tangent. So if tangent's opposite over adjacent, what's the flip?
Opposite. Oh, adjacent over opposite.
Adjacent over opposite, which is 5 over 12. Perfect. So it really helps to label your adjacent, opposite, and hypotenuse. And then for each one, you just have to look back at the triangle. There's not a lot of math going on, it's just plugging it in. All right, 1, 2, and 3, we have to do the same thing, find our 6 trig functions. So first thing we want to do is find our missing side. So if this is theta, what would 3 be? Is it opposite, adjacent, hypotenuse?
Opposite.
It is opposite. What's 4?
Adjacent.
Adjacent, and then we need to find what our hypotenuse is. So how can we find our hypotenuse?
Pythagorean Theorem.
Pythagorean Theorem. So a squared plus b squared is equal to c squared. What's our a?
4.
4 squared. What's our b?
3.
3 squared. And then c is our hypotenuse, which was what we're trying to find. So c squared. 4 squared is what?
8. Or 16.
16. 3 squared would be 9. That's equal to c squared.
9.
What's 16 plus 9?
25.
25. So if 25 is equal to c squared, what's c equal to? 5. Perfect. Just take the square root, c is equal to 5. So 5 is our hypotenuse. So now we have to find sine of theta, cosine theta, tangent theta, and each reciprocal, so that would be cosecant theta, secant theta, and cotangent theta. And don't forget, we have so, ca, toa to help us out. So sine is what?
Opposite over hypotenuse.
Opposite over hypotenuse. It's so, opposite over hypotenuse.
3 over 4. Oh wait, 3 over 5.
3 over 5, perfect. What's cosine?
Opposite over,
Adjacent over hypotenuse. So what would our adjacent over hypotenuse be?
4 over 5.
4 over 5, and then we have tangent, which is opposite over adjacent, toa, opposite over adjacent. What's our opposite? And our adjacent? 4. So we have 3 over 4. Now we know secant is the reciprocal of sine, so we can just flip sine. So instead of being 3 over 5, we have 5 over 3. Secant's the reciprocal of cosine, so instead of 4 over 5, we have 5 over 4. And cotangent's the reciprocal of tangent, so instead of 3 over 4, we have 4 over 3. So we just flip the respective reciprocals. Ready for number 2? Alright, so our theta's up here now. What is 15? Opposite.
Adjacent.
Remember, it's not next to it, it's across from it, so it's opposite of our theta. What is 17?
Hypotenuse.
Hypotenuse. So we have to find the adjacent. How can we find the adjacent? The a squared plus b squared equals c squared. So the Pythagorean theorem. What's our a squared? Or what's our a? 15 squared.
15.
And then what would our b be?
17 squared.
So remember, it's equal to the hypotenuse squared. So that 17 has to be our c. So b we don't know yet. B is one of our sides. We got to figure it out. So we're solving for b squared. So what's 15 squared? 225. What's 17 squared? What is it, Brooke? 289. So then we just subtract 225 on both sides. So we get b squared is equal to, what's 289 minus 225? 64. Then we take the square root. And what's b equal to? 8. So our adjacent is 8. Everybody with me so far?
Yeah.
All right, now we need to find our 6 trig functions. So we have sine theta, cosine theta, tangent theta, and then they're reciprocals, so cosecant theta, secant theta, and cotangent theta. So sine is what over what? Opposite over hypotenuse. So what's our opposite?
15
And what's our
over
hypotenuse?
17.
17. Our cosine is what over what?
Adjacent over hypotenuse.
Adjacent over hypotenuse. So what's our adjacent?
18 over 17.
8 over 17. And then what's our tangent?
Opposite over hypotenuse.
So TOA. Opposite over adjacent.
Opposite over adjacent.
What's our opposite?
15.
And what's our adjacent?
8.
8. So what's our secant? Or cosecant? Our cosecant.
17 over 15.
Awesome. We just flip it. So 17 over 15. What's our secant?
17 over 8.
17 over 8.
And 8 over 15.
And then 8 over 15. Perfect. All right, let's take a look at number 3. So our theta's here. What would 5 be? 5 is adjacent. What is 5 square root 2?
Hypotenuse.
The hypotenuse. So we're missing the opposite. How do we find our opposite?
Pythagorean Theorem.
Pythagorean Theorem. So we have 5 squared plus, what would our b be?
Opposite.
Opposite, which we don't know, so b squared is equal to our hypotenuse squared, so 5 square root 2 squared. So our 5 squared is 25 plus b squared. How can we square 5 square root 2?
Doesn't the 2 cancel out the square root?
So the 2 applies to the 5 and it applies to the square root 2. So yes, it cancels out the square root, so we're just left with 2 here. But what is 5 squared?
25.
25. So we have 25 times 2. So everybody sees how I got that 25 times 2?
Oh, so you just save you multiply it, but then you keep the 2 there?
Yeah, because like you said, the square root 2 squared, the squared and the square root cancel, but we still have that 2 there.
Oh, okay.
So we have 25 plus b squared is equal to 50. Then how do we solve for b?
Subtract 25.
Subtract 25. So b squared is equal to 25. And what's b equal to?
5.
5. Perfect. So our opposite is 5. So now we need to find our 6 trig functions. We have sine of theta, cosine theta, tangent theta, cosecant theta, secant theta, and cotangent theta. So our theta's up here. Sine is what?
Opposite over hypotenuse.
Opposite over hypotenuse. So what's our opposite?
5 over 5 over
5 over 5
Okay.
square root 2.
We just leave it like that? We don't change it?
We can't leave it like this. So can we simplify 5 over 5 square root 2?
cancel out 5.
The 5's cancel.
Oh, actually?
Actually, Lexi, you're on a roll today. 5's cancel. So we have 1 over square root 2. We can't have square roots in our denominator, so how can we get rid of that?
Oh, no.
Can you square the fraction?
We can't square it because we don't want to change the value of it. But can
Square the denominator
can we multiply our numerator and denominator by something?
by 2.
Well, multiplying the top and the bottom by 2 would just give us still a square root on the bottom.
Oh, dividing it by 2?
So we want to rationalize it by multiplying the top and the bottom by square root 2.
Oh,
Because what's square root 2 times square root 2? On the bottom here. Square root 2 times square root 2.
Oh.
Perfect. So we get 2 on the bottom, and then 1 times square root 2 would just be square root 2. So this is our answer. You have to rationalize it. You can't leave that square root in the denominator.
oh.
Now let's do cosine. Cosine is adjacent over hypotenuse. So what's our adjacent? 5.
5.
And what's our hypotenuse? 5 square root 2.
Squared. Yeah.
So what do you notice about our cosine and sine?
They keep
They're the
canceling out.
same. They were the same thing. So we know we're going to do the same math that we just did for sine, again for cosine, and we get the same thing, square root 2 over 2. Because the 5's cancel, then we have to rationalize, and we get the same answer. Now let's do tangent. Tangent is opposite over adjacent. So what's our opposite? 5.
5.
And what's our adjacent? 5.
5. So it equals 1.
So it equals 1. Perfect. Now we just have to flip them all for the reciprocals. So when,
Can't
Lexi, what was your question?
leave the if you flip them, then the denominator is going to have a square root.
Right, so we actually want to flip the original. So we had 5 over 5 square root 2, so we're going to say 5 square root 2 over 5.
Oh, okay.
What happens to the 5's?
They cancel out.
They cancel, so then what are we left with?
Square root 2.
Just square root 2. What about secant?
The same thing, so square root 2.
Awesome, same thing, we'd get 5 square root 2 over 5, which simplifies to square root 2. And then cotangent.
1.
Perfect, it'd be 5 over 5, which simplifies to 1. Awesome. All right, let's look at example 2. In a right triangle, theta is an acute angle and sine of theta is equal to 4 over 7. Evaluate the other 5 trig functions of theta. So for these, we kind of have to work backwards. If it helps, draw the triangle. So we have a triangle here. We can say this is theta. Sine is what over what? Opposite over hypotenuse. So 4 is our opposite and 7 is our hypotenuse. So opposite of theta would be 4. Opposite of our right angle, so our hypotenuse would be 7. How do we find the missing side?
Pythagorean Theorem.
Pythagorean Theorem. So we're looking for our adjacent. So we have 4 squared plus, what's our b?
7 squared. Wait. Oh no. B squared.
B squared is equal to our hypotenuse, which is 7 squared. So 16 plus b squared is equal to 49. Subtract 16 on both sides, so b squared is equal to
33.
33. Take the square root of both sides. So b is equal to the square root of 33. So our adjacent is the square root of 33. Not a pretty number, but we'll make it work. So let's find our other 5 trig functions. We already have sine, which is 4 over 7. So we need cosine, theta, tangent, theta, cosecant theta, secant theta, and cotangent theta. So cosine is what? What over what?
Opposite over hypotenuse.
So remember, cosine is adjacent over hypotenuse. So adjacent over hypotenuse. What's our adjacent? Square root 33. And then our hypotenuse is?
7.
7. What's our tangent?
Opposite over adjacent.
Opposite over adjacent. What's our opposite?
4 over square root 33.
4 over square root 33. We can't have a square root in our denominator, so what do we have to do to it?
Multiply them by 33.
Multiply the top and the bottom by square root 33. So on the top, we get 4 square root 33. What's square root 33 times square root 33? They cancel, so it's just 33.
Wait, what did you do? Sorry?
Square root 33 times square root 33 is 33. When you multiply a square root by the same thing, it's like squaring. It's like square root 33 squared. So you just get rid of the square root and keep 1.
Okay.
All right, what would cosecant be?
33. Oh, 7 over 33?
Cosecant, remember, goes with sine.
Oh, then 7 over 4.
7 over 4. What about secant?
7 over 33.
7 over square root 33. Can't have square root 33 in the denominator, so what do we have to do to it?
Multiply them by square root of 33.
Multiply the top and the bottom by square root 33. So what do we get on the top?
7 square root 33.
7 square root 33, and then 33 on the bottom. Perfect. And then cotangent would be what?
Square root 33 over 4.
Awesome. Square root 33 over 4. So we just flipped the original here. All right, so here it gives us cosine is equal to 7 over 10, and we have to find the other 5 trig functions. So cosine is what over what?
Opposite over, adjacent over hypotenuse.
Adjacent over hypotenuse. So SOHCAHTOA. Adjacent over hypotenuse. So we could draw our triangle if it helps you. Let's say our theta is down here. Adjacent is 7. Hypotenuse is 10, so we're missing the opposite. How do we find our opposite?
Theta.
It doesn't matter because we're drawing our own triangle. Like I could put my triangle like this and make theta appear. It doesn't matter because what matters is like this is still opposite, which is still what we need to find. This is still adjacent, which would still be 7. So it really doesn't matter when you draw your own triangle where each thing is, where your theta is.
Okay.
How do we find our opposite?
Pythagorean Theorem.
Pythagorean Theorem. So we have 7 squared plus, what comes next?
B squared.
B squared is equal to?
Squared.
10 squared. So we have 49 plus b squared is equal to
100.
100. How do we solve for b?
Minus 49 to both sides.
Subtract 49 on both sides. So b squared is equal to
51.
51. Take the square root of both sides. So b is equal to the square root of 51. And then it just asks us for our other 5 trig functions. So here we have to find sine. It gives us cosine and tangent, and then cosecant, secant, and cotangent. I'll finish this in the video.